Hi, it's been a while. I assure you that Annoying Integral Part 3 is coming out soon. I've, recorded half of it this morning, but I didn't want to rush it, because quality over quantity. But at the same time, I didn't want my channel to be absolutely dead after, 4 videos, so I'm gonna put this out, and this is kind of like a question for you to solve, or attempt to solve, but I'm sure you'll get somewhere. I don't want to yeah, whatever. But yeah, here's the kind of things leading up to the question. So on screen you see the non-negative integers n and the corresponding nth Fibonacci number f sub n, and I'm sure you know a lot about the Fibonacci numbers, but yeah. So f sub n has this explicit formula, phi to the n minus negative phi to the negative n divided by root 5. This is called Benet's formula, where phi is 1 plus root 5 over 2. Golden ratio. Classic. And we are going to manipulate this a bit because, well, you'll see. So we're going to split the power thing up into 2. And then negative 1 to the negative n is just 1 over minus 1 to the n, which is just minus 1 to the n. So we can get rid of that minus sign. And this is our current situation, which is only valid for integer values of n. But here's, the ultimate question. What if n wasn't restricted to being an integer? What if it could be a real number? Well, it can't be, because negative 1 to the n, it won't work, will it? Because negative 1, it can be only raised to an integer power. Except if we allow complex numbers to exist. So if we have not f of n now, not f sub n, not f sub n, but f sub t, where t ranges from 0 to infinity as a real number, f sub t will be complex except when t is an integer, but that's okay. And you might have seen this before, because this was inspired from Matt Parker's video of complex Fibonacci numbers. I'm going to link that in the description, because I watched that, and, well, it was 3 years ago, but it popped up in my recommended, so, sparked the idea. So he plotted f sub t when t ranges from 0 to infinity, and he used minus 1 is e to the I pi, not e to the 3 I pi or anything, because that will ultimately become e to the I pi t. And then, things kind of happen, but yeah. But anyways, he plotted it out. He plotted f sub t out, basically parametrically. And this is the complex plane. What he got was this sort of curve, right? Which kind of makes sense. This is 0. It goes through 1 twice at t equals 1 and t equals 2. And it goes through 2, 3, and then 5. So I saw this graph in his video. And as an integral person, whenever I see a graph, I look for areas. And oh, what do I see? I see this area right here. So the question is, what is this area? Right? If I is quite far up, by the way, because this graph is scaled weirdly, but I is there. If this was 1 unit, if I is 1 unit away, and 1 is obviously 1 unit away, what would be this area? That is the question. And I'm going to leave it for you to try out, because it's interesting. So yeah, maybe I'll put the solution out soon, but that's kind of the thing right now, the situation. Don't want my channel to be dead, so I'm posting something. But yeah, anyways, see you soon.